I wanted to present you one of the way that we do, I mean, that we use here to run some inference of large pre-trained models. Uh, some of them are available from Hugging Face. My presentation is based on a Python module called the LLM, which is quite a large project. Um, First of all, I'm going to be very brief about this. Like presenting, I mean, our platform and our team, because I want to really take the time to show you the script that I've prepared. And what I would like us to do is to really have some, like I'm going to make you a demo. And as soon as there is something that isn't clear, please interrupt me, because my goal here is really to show you how I run these inference. So we have a supercomputing application service team to which I'm part of. We are 4 HPC software engineers, 2 support engineers, and there is a trainee. We have various missions. So this small team is basically responsible for user onboarding, offboarding, so management of the projects that are running on our platform and so on. We also take care of deploying the software stack. And on top of that, we do some performance debugging, for example, for our users that are not that are having scaling issues, and also that are facing bugs that they can't solve. And also we, of course, have a lot of HPC related tasks, starting with some technical reviews, and also we um, we are involved in the Epicure projects, which are very interesting. Shortly, so I'm going to skip that part. Just a quick word. So on our platform, it's a bit of a unique platform because we have users from the research ecosystem, but also users from businesses. I mean, by some from private businesses. And so we have all type of users on the platform, which make our lives as HPC software engineers even more challenging, let's say, because you have really a large variety of user requests. In short, we have, let me directly go to the infrastructure essentials. We have 4 different partitions. Standard, I would say, CPU nodes, 20 FPGA nodes, and we have, on top of the 20 large memory nodes, we have 200 GPU nodes. Each of them is equipped with 4 NVIDIA A100s. And we are going to, I mean, in the demonstration that I'm going to run, this is the type of nodes that I will be using. I'm going to skip that part. You can refer it to later, or of course you can ask me a question at the end of the talk on that part. So I saw that you had a lot of talk before mine on Hugging Face. Just as a quick recap, as you know, Hugging Face is a kind of central repository where you can find pre-trained models, public data sets, and demos and scripts. So today, I have restricted my talk to an NLP, let's say, task. But of course, keep in mind that Hugging Face offers much more than this. Um, And there are a lot of on the pre-trained models that I offered on Geekface. There are a variety of model architectures that are offered. Some of them are very well known, like BERT, GPT, or T5. And what's nice is that Hugging Face can, I mean, if you want to make some quick tests on some small models, Hugging Face Spaces allows you to do that. You can quickly via the GUI, you can quickly test some sentiment analysis models and so on. Unfortunately, this is restricted to small models. As soon as you want to, and yeah, of course, you can use some API to test those free models. But as soon as you want to, let's say, test something bigger, unfortunately, uh, you cannot go for the free option anymore. You have to pay. To make a long story short. Um, and one of the possibilities that you have to test bigger models, for instance, is to use an HPC platform, to which, of course, you would need access to. And so today, what I'm going to show is an inference of such a large model where you can't have the free, you cannot test for free on Hugging Face. And we are going to run the inference of such a pre-trained model on MeluXina. But this model is so large that using only one node of one GPU node of MeluXina, equipped with four GPU cards, as I was mentioning before, would not be sufficient. So you directly hit, let's say, quite a challenging task, which is to run a distributed inference, so multi-node, multi-GPU inference of a pre-trained model. And the question is, yeah, what tool shall I use to run uh, such an inference of a large model? So what we will see today is the inference of a mixture experts model, so the one with a 46 billion parameter. I'm going to very quickly give an overview of the generic, let's say, working principle, and let's say the core of this talk will be the demonstration that I've prepared for you to be run on MeluXina. And then, of course, there will be, if you wish to, some Q&A session. So in general, the working principle is simple. You have a client, and via this client, you submit some requests to your to your model, which then returns a response. I don't know why I was so proud of my graphics, but there have been the format changed somehow. Anyway, so the working principle, let's say more in detail, is that you have a client, and here what we will have, we will have a model, an inference um, server running on 5 nodes. There will be an head node which act, let's say, as an orchestrator, and this head node will propagate, if you want, the requests and the different and the sequentiality of the tasks, the of the layers being traversed by of the model will go through different worker nodes until the moment where we will go back to the head nodes that will output uh, the aggregation of the model response. And all of this is, of course, handled by the Slurm um, workload manager. A small, let's say, technicalities that in this demonstration to make things simple. If you want, the Python client is also, let's say, running on the head nodes, and I will connect to it via my laptop via an SSH port forwarding connection. So the demo. Before this, sorry, I'm just going to mention the fact that so there I will share my slides, but I've put, let's say, some basics on how to connect to MeluXina, how to create an Hugging Face account and get a token. Of course, but maybe you mentioned it in the previous talk. Do not forget to have this Hugging Face Hub API token environment variable set up. and to get the access to the model you need on Hugging Face. So I've already I've done these steps on my side, and of course you can reproduce them later if you want to reproduce this demo. But I guess that you're all set up already from the talks that I saw before. So um, let me start. Um, so very shortly, I connect to the platform. I of course get to the directory where I have hosted the file. By the way, I put everything into a repository such that you can have a look later. I put the launcher, the Slurm launcher, and all the code that is needed to reproduce sorry I've put here. I also put like an extensive amount of instruction in the case where you are interested in what I'm showing here. Um, okay, let's open my inference scripts. I don't know what is the, let's say, level of the audience in terms of Slurm launchers and such. So if I'm going too slowly or too fast, please let me know.
It is absolutely fine, Marco. I think it is at the level of detail, at the appropriate level of detail. It's fine.
Okay, okay. So here, in the part that I'm highlighting, you can all see my bash script. Is it fine?
Yes, yes.
Okay. So here I'm highlighting the basic setup of my Slurm launcher. So I'm using my account on the default QoS. The important thing is the following. So I'm using the GPU partition and I'm using 5 nodes. And on these 5 nodes, I am this will be useful later. I'm using so on each node, if you want, I will have one task, and this task, which will be handled by VLLM, will be using 4 GPUs. Here, I I am loading the necessary modules that I will be needing. So here it's just that on our platform we offer different stacks, and if you want, every year we update the stacks, but we leave the stacks from the previous year available. So this is why I'm specifying the stack I'm using, and I will be using Aptainer. You are going to see why. So once again, it's important to have the Hugging Face API token always available. At least this is what I'm always doing. And also something important in my perspective is the fact of having um, a directory on which Hugging Face will put is the shards of the model, and of course this directory must have sufficient space. So on our we have unfortunately a quite a strict policy on our platform regarding if you want the number of inodes and the the storage that is available for each user. So in my case, I'm lucky because I don't have a restriction on certain partition on certain tiers. But if you want, in any case, there is someone that will be from the audience that will be using MeluXina in the future. We have this myquota command that allows you to see where you are in terms of storage occupation that your user has. So I'm gonna use, if you want my Hugging Face cache directory, I put it on a tier 1 storage, and on this one, because I don't have a restriction in terms uh, of storage, and this is where I'm going to store my shards. And of course, it's important to be consistent, let's say from run to run. What I really enforce where I put my shards, because then, of course, when I really the shards will be downloaded once, and then in subsequent run, they can be easily imported again without downloading them again. Um, so a tip, this is at least what I do for myself, is that I am so annoyed at this point, with creating every time for every, let's say, different task. Sometimes you have to create a different Python virtual environment. I find that very annoying. What I found is very convenient is to use this container image that is offered by VLLM, which contains everything we need. In the sense that we have PyTorch available and all the Python modules that we need to properly run our inference without taking care of dependencies and losing time using pip to solve possible issues with package dependencies. In the script that's so I will provide you, I've provided you via my GitHub repo. If the CIF image is not found, I already download. You have everything that is downloaded, such that you just have to run this script and you're good to go. Something important here. So as I was saying, I'm using a container image to run VLLM. Something important is the fact that you provide the NV CCLI command line to the as an apptuner argument. Why we need that is to ensure that that what it's actually doing is that it's injecting the appropriate NVIDIA runtime dependencies in your container, such that your container can, between brackets, see the GPUs that see your hardware configuration, in short. And also, we need to map the cache directory on which I have stored my model shards with the root directory of the container. This is what I'm doing here, to make a long story short. And also, as you can see here, I am setting the HF home, so inside the container. Um, the Hugging Face model that I will run here is so the mixture of experts. And so here, if you want, in this part, I hope it was not too boring, but this is, let's say, my initial setup. I'm making everything ready for the container to run appropriately. And as a side note, so I have written this file in such a way that if you want to test another model, the only line that you will have to change is this one. So if you want to test inference of another model, this is the only thing that you will have to change. Um, of course, be careful. VLLM works only with a set of models, in the sense that VLLM supports, if you want, certain model architecture, but not every, let's say, every model architecture that you must think of. So one has to check the VLLM documentation to see which model, let's say, are compatible with VLLM. Okay, so if I go back to my short, let's say, overview. So what I will do, I will set up the head nodes and the worker nodes such that they are up and running. So this is what I am doing here. So if you want, this is the commands that I will run with Aptainer. So I will, if you want, I will start a head nodes, and this head nodes is going to have a port, let's say, open for communication with the worker nodes. So I start the head nodes, I start the worker nodes, and so here you see I start the head nodes with, this is a bit heavy in terms of syntax, but it looks much more difficult than what it is. So in the end, you have a srun command, and if you see much later, you have this Aptainer command, and you see I'm here I'm executing, so with the upturner arguments that I mentioned before, I'm running the container image with the command that I prepared for the head nodes. And in a similar fashion, I start the worker nodes in a very similar fashion. Uh, just here as a detail, you see that I am enforcing this srun command to run on the head nodes. And here, of course, I am excluding the head nodes, which is logical because I start this command on the head nodes, and on the remaining nodes, I run this command. All of this to um, to do what? To do this command. So how does it work? So I run again, so obtainer with the proper arguments, and this is the core of the thing. I serve my Hugging Face model, and if you want here, I indicate that I have four sorry, that I have the tensor parallel size is the number of nodes that I'm using, so 5 nodes. So if you want, what does it mean? I serve my mixtural model on 5 nodes, and on each node, I'm using here 4 GPUs. This is, let's say, the last line of our script is this one. So I hope that I didn't lose anyone. I can now. Oh, let me see. Let me see if. I'm sorry. I have forgotten the reservation name. Oh, I can. Okay, so it's running. Oh, no, sorry. Let me start again because I launched another server before. Sorry, it's a bit slow. In the meantime, are there some question yet, or some stuff that you want me to explain again?
I would like to underline that this code is ready. Marco presented previously a repository on GitHub where the code is available. So actually, the presentation now is to understand the code, but when you want to run the code, you simply change or keep the same LLM model and send this script with a standard slurp command.
Exactly.
So if you find this complex, you don't need to rewrite everything. The script is ready, and you just run it. You run the batch script, and you.
Yeah, so I prepared everything with the instructions that I try to detail as much as possible. So I'm gonna share this one on the chats.
Yes, great.
I don't know why is it so slow to kill the job. That's the demo effect. Never took that long to kill a job.
Yes.
Unbelievable.
I think now the new
Okay,
plan.
it's running. So, if you want in the what we did, so sorry, which job is it? So 202 47. Maybe something. 202. My script is my screen is really tiny. I'm struggling to. Okay, so everything is running. Okay, so what I prepared is if you want in the output file, I made so there is this line. This is simply speaking a command that you must copy and paste in your local terminal. I'm going to show you why. If I so because now I should have explained better. Now, if you want, our inference server is running. Okay, that's nice. But how do I interact with the model? So what I did is that, so here I am on my, I'm not on MeluXina anymore. I am on my local laptop. It's a terminal on my laptop. I copy and paste the command that is in the output file of the Slurm job, and I prepared a small, uh, sorry, I prepared a tiny Python script. Once again, everything is in the repository that I prepared for this talk. And you have a very simple, let's say, GUI to interact with the model that is running. Okay, okay, that never happened to me
The
before.
demo effect.
Uh, yeah, that's unbelievable. Oh,
Yeah.
uh,
While solving this, I would like to underline that now two things. The first thing is that we have allocated 5 nodes. Each node on MeluXina, Marco mentioned this, but I would want to underline this. Each node on
mm,
MeluXina has 4 ampere GPUs of
yep,
40 gigabyte each. So now we have 20 GPUs allocated with
exactly.
40 gigabytes RAMs. It's almost 1 terabyte GPU RAM. Okay, so this is a huge, this is a very big anyway infrastructure now that we use. And the second thing is that with this script, we start a server on MeluXina, and we can request this server from our local laptop. We can ask it something from our local machine.
That's working.
And also Marco prepared a UI. This is a Gradio app for the UI. I'm doing this.
So, but what I found convenient, if you want, is really the fact that for a non-expert in model inference, like the non-expert that I am, I think it's very convenient to deploy an inference server of a large pre-trained model. And if you are able to, for example, fine-tune a large model and the architecture of this model is compatible with VLLM, you can quickly run an inference server. I find it very nice. And for a non-expert, I think it's a very nice solution. I can imagine that when you see the scripts that I have shown before, sorry, it's a lot of information for, let's say, at first it's a lot of information, but I hope that with the all, let's say, the comments that I put on the GitHub repository and on the script that I have really commented heavily, I hope that you will learn something. And once again, if you just want to test inference of a Hugging Face pre-trained model, you just change this line. Of course, you must ensure that you have been granted the access to this model, and that's all. The rest is taken care of by VLLM, and as I was explaining before, you don't even have to care about the dependencies because everything is included in the obtainer image, the obtainer container that I'm using on that demo on the here, this guy. And yeah, so then you can give it a try. Um, just to So this you can reproduce. So as a recap, the first step is, but I think this has been covered in previous talk, is to just take care of the small things that you must set up before in order to use Hugging Face pre-trained models. So do not forget to set up the cache directory where if you want the shards of the model are going to be downloaded, and this can take really a lot of space. Do not forget to define your token as an environment variable. Um, and so what I've shown you today is how to run this distributed inference using VLLM and Ray, which is another library that I used. And you have seen, but I think that I could not catch everything in the previous talk, of course. But if you want to set up a chatbot-like GUI and test it very quickly, you can use the Python snippet that I have prepared from your local laptop, and you directly interact with a model running on MeluXina, which I find quite cool. Of course, so I'm open to question, but we have a documentation for the people that might use our platform. If you have an issue or if you want to have a technical discussion, we are reachable via our service desk um, ticketing platform. And I prepared for you other pages that you might be interested in. So there is another way that we have documented to run an inference, which is setting up a Triton inference server. Just for you to see if you're interested how VLLM simplifies the distribution of an AI, let's say, related workload on a cluster, you can check this training. This code which trains a fictitious ResNet model, and you will see how difficult it can quickly become when you have to take care of distributing training or inference. In case of performance issues, we also, and let's say you have a training or an inference code that you would like to profile, you want to understand where you lose time. We have some tutorials on how to profile your code when running on MeluXina. There is a VLLM documentation, which is they really spend a lot of effort writing it. In particular, for the people interested in testing what I've shown, you have the list of compatible architecture. Um, you should definitely have a look if you are interested in running this inference server. And of course, there is the Hugging Face website that, but I guess that you all know it. Uh, I thank you for your attention. I hope it wasn't too heavy, and please do not hesitate to ask me questions.
Thank you, Marco. I have a small question. If the server is still running,
Hmm.
I was wondering, I presented previously Llama small 1 billion on
Hmm.
Colab, and I was wondering if we can ask the same question now Mixtral to see how it responds.
Yeah.
I share the question in the chat, the prompt I gave to Llama. It is explain linear regression using LaTeX, but use D as dependent variable. So Llama 1 billion wasn't able to. I also presented Llama 8 billion that was able
Hmm.
to reply correctly. Let's see now what will happen with
But
an
for
even
the
bigger model.
mm,
Yes,
I'm not
this.
sure it's able to handle the.
We can see D equals B0 plus B1 times I. So it replies correctly. And it explains here D represents a dependent variable. Great. Yes. And I mean, this is the reason why we need bigger models because we have they are better in more difficult tasks like reasoning and more complex thinking, etc.
Yeah, and I mean, there is a lot that I would like to test, but unfortunately, I'm very busy. I would like to know. I mean, as future work, I would like to see if it can handle multiple, multiple requests at the same time, and how does it perform? Um,
You
and
need to
also,
distribute the request somehow. I think you need some another software for multi-processing. I don't think that the same,
yeah,
the
exactly,
model itself, yes.
exactly.
Uh, we have also one question from Vasilis. Vasilis will present right after the Greek LLM Eltemi, from Athena. And we have a question, if you keep a track of the energy consumption of the nodes.
So we had to implement that. It was a Euro HPC request.
Hmm.
If you want, we have an estimation of the energy consumed at the end of the once the job is terminated. Uh,
Hmm.
it's a
Yes,
plugin that has been coded to estimate, yeah, the energy consumption.
yes. There is a big discussion now because of the climate, etc. So this is very
Mm.
important. Any other questions? So, what is an average energy consumption of a medium-sized task in watts?
Oh,
I don't know.
I don't know.
Hmm.
I don't know. I can have a look later, but I'm not the one working on those
Yes, I guess
aspects.
it is a bit more complex because it's not only the GPU, the watts of the GPU, but
Mhm.
also the cooling system,
Yeah.
etc. So,
Of course, you can monitor your GPU power consumption in using NVIDIA SMI, but
NVIDIA SMI gives also the energy.
yeah, yeah, yeah. For instance, if I check,
Does it work for multiple nodes, NVIDIA SMI?
sorry, can you repeat?
NVIDIA SMI works for multiple nodes. Now we
Yeah,
can
yeah.
see all the nodes. Okay. Yes, so we are.
So far there is nothing.
It is not running.
No,
Yes.
no, it's nothing. There is nothing running.
78 watts out of 400, but we have, if it is fully running, so it is 400 per GPU. We have 20 GPUs, so 8 kilowatts, if I counted correctly, 20 times 400.
I'm wondering, because that was the head node, I'm wondering what's going on a server, on the, yeah, one of the workers. Nothing is running. I mean, you have the idling, the process that are idle because I'm not doing anything.
Yes, yes. Now it is waiting for the prompt. Yes.
Let me see if we see something. Yeah, you have seen there was a peak.
A peak of 50%. Yes,
Yeah, yeah, yeah.
yes. Mm.
But I guess it's very light for, I mean, it's not an intense workload.
Yes, because I guess that by using this server, multiple, it can receive multiple requests, right?
Yeah, I guess so. Yeah, yeah, yeah.
Yes, yes,
But anyway, I wanted to share this workflow using VLM. I think it's to me at least it simplifies quite a lot the
yes, absolutely. To run it in one node, it is quite straightforward. To run it in multiple nodes, it is very difficult, and I find this very useful. And it is necessary if you want to run big models. It is necessary to have, I mean, multiple nodes.
yeah. And the issue we have multiple users that are facing difficulties because we have the limitation coming from the fact that we have only 40 gigas of VRAM. And
Yes.
if you want that technical specificity is really annoying
Mm.
because you have some standards model that do not fit on those 40 gigas. And in this case, you must use some parallelism strategy, um, which is, of course, for some users, an additional layer of complexity.
Yes, absolutely.
Well, in any case, if you want to, if for the audience, if you have further questions, do not hesitate to drop me an email or just let me know.
Yes. You have the details on your presentation, Marco, right?
I will, you know what,
The communication
uh,
details, I mean.
I will add because I have a difficult to pronounce.
Okay,
Uh, uh, at,
okay, great. Thank you very
I
much.
will upload the presentation. What does it take for us to use MeluXina? What do you mean?
No, this email, if you have the email
To have access.
to for what you just did, it is fine now. I mean, because we will share the presentations if somebody wants to ask
No,
you
no,
something.
sorry. I was reacting to Lazaro's message in the chat.
Ah, sorry,
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 sorry.
sorry.
Sorry, okay. What does it take for us to use LuxProvide to have access?
The thing is that there is, as this is a super secured platform, there is like quite a heavy process um, to get access. But I can, if you contact me, Lazarus,
Uh,
I can ask. Um,
we can also help there. I share a link from our website with information how to apply. You apply through the Euro HPC JU calls.
exactly.
I have details inside the link, and we support. Part of our role is to support your application, the application to support the application process, to explain how to apply for access, etc. So Lazare, you can have a first look and all at the at this URL. And if you have questions, please contact us as well, and we will guide you through the process. I think here we finish with Marco's presentation.